Okay, I want you to take a second right now. Seriously, don't move. Just focus on the center of your chest. Do you feel that? There's this steady, rhythmic cadence happening right now inside of you, completely without you even thinking about it. One beat, then another, and another. Welcome to today's Explainer. We're going to unpack the science of literally the ultimate biological machine.
It really is the ultimate question, isn't it? Like, have you ever actually wondered, why does the heart beat? I mean, who tells it to beat? And why on earth doesn't it just stop while you're sleeping? Most machines need a break, a little downtime for maintenance. But your heart? It never asks for permission, and it certainly never takes a vacation.
Over the course of your lifetime, this incredible biological engine sitting right inside your ribcage will beat more than 3 billion times. 3 billion. That is just a staggering number to try and wrap your head around. It's a true testament to an absolutely flawless biological design. To put that into a daily perspective, it beats over 100,000 times every single day. Think about how exhausted your legs get after just, a few thousand steps. Yet this pump fires 100,000 times a day, every day, right from the moment you're born. No way you could do that with your legs, right?
Okay, let's dive into this. For all you focused learners and students joining us, here's our roadmap for today. We've got 1. Meet your eternal engine. 2. The body's built-in battery. 3. Why it never gets tired. 4. The secret of lub-dub. 5. Shifting into high gear. And finally, 6. When the engine stops.
All right, Section 1, meet your eternal engine. So what exactly is the heart? A lot of people think it's just a regular muscle, kind of like your bicep or your calf. But actually, scratch that. It is a highly specialized, dynamic pump made almost entirely of unique muscle tissue designed for one specific vital task. If you want to know exactly what we're dealing with here, just hold up your fist. Go ahead, hold it up. That's roughly the size of your heart. It weighs between 250 and 350 grams in most adults, and it sits just slightly to the left of the center of your chest, perfectly protected by your ribcage.
And its job? Well, it's simple but monumental. Circulate blood. Every single minute, this tiny 300-gram pump pushes about 5 liters, that's roughly 1.3 gallons, of blood throughout your entire body. To put that in perspective, without this constant circulation, your brain would run out of oxygen in just a few minutes. Literally, your entire life depends on this 5-liter per minute cycle.
Moving on to Section 2, the body's built-in battery. Now, here is a fantastic question, especially for those of you taking notes. Who actually tells the heart to beat? You might assume your brain manages every single heartbeat, micromanaging the rhythm second by second. So the crucial point is this critical vocabulary term right here, the sinoatrial node, or the SA node. This is a tiny group of specialized cells located in the upper right chamber of your heart that acts as your heart's natural pacemaker. It produces tiny electrical impulses completely all by itself. It is, quite literally, your body's built-in battery.
Let's see how this perfectly timed sequence unfolds. Oh, and students, heads up, this is highly testable material if you're studying biology. Step 1. The SA node fires. Step 2. The electrical signal spreads, causing the upper chambers, the atria, to contract and push blood down. Step 3. The signal hits a sort of checkpoint called the AV node. And finally, Step 4. A fraction of a second later, the lower chambers, the ventricles, contract powerfully, pumping blood to the lungs and the rest of the body. Over and over, every second of your life.
All right, Section 3, why it never gets tired.
I want you to imagine holding a really heavy weight out in front of you. After just a few minutes, your arm starts to shake, right? Your muscles burn. They become utterly exhausted. So why does your heart muscle, which works every second of your entire life, never experience that same exhaustion? Well, the answer comes down to cellular engineering, and specifically this term, mitochondria. You've probably heard them called the powerhouses of the cell, and for good reason. Heart muscle cells are absolutely packed with enormous numbers of mitochondria to produce the massive amounts of continuous energy the heart demands. And this just brilliantly illustrates the heart's flawless feeling and cooling design. It has its own dedicated blood supply through the coronary arteries, making sure there's a constant delivery of oxygen and nutrients. It has those massive reserves of mitochondria we just talked about, and crucially, it works in cycles. After every single beat, the heart actually relaxes for a tiny brief moment. These micro rests happen thousands of times a day, and together they keep the engine running for decades without failure.
Next up, Section 4, The Secret of Lub-Dub. When a doctor places a stethoscope on your chest, what are they actually listening to? Most people assume they're hearing the heart muscle itself squeezing, but that's not the case. They're actually listening to the mechanical components of the engine, the valves. Lub. That first sound happens when the valves between the upper and lower chambers snap shut. They're one-way doors, making sure that when the heart squeezes, the blood only moves forward, not backward.
Dub. That second sound marks the closure of a second set of valves, the ones leading out to the lungs and the rest of the body. Lub, dub, lub, dub. That incredibly familiar rhythm is actually acoustic proof that your heart's valves are acting as perfect one-way doors, making sure your circulation stays highly efficient.
Let's speed things up in Section 5, shifting into high gear.
So what happens when things speed up? Think about when you're sprinting, or, I don't know, sitting in the theater watching an incredibly tense, scary movie. Your heart starts racing, right? Suddenly, your tissues are burning through oxygen, and your body realizes it needs more blood fast. Now, what's really interesting about this is how the nervous system communicates with our engine. Your brain releases hormones like adrenaline. Adrenaline acts exactly like a throttle. It commands that SA node, our built-in battery, to fire those electrical signals much more quickly. Your heart rate spikes, delivering way more oxygen to your brain and muscles, preparing you for action.
Just look at this comparison. In a resting state, an average adult heart beats between 60 and 100 times per minute, pumping those 5 liters. But in a highly active state, flooded with adrenaline, this incredible machine can pump upwards of 20 liters per minute. That's 4 times the normal volume. And for our students focused on sports science, note this. Athletes often have slower resting heart rates simply because their hearts have become so strong and efficient at pumping blood, they honestly just don't have to work as hard while resting.
Finally, Section 6, when the engine stops.
We have to ask the serious question here. What happens when this perfect system fails? What happens during cardiac arrest when the engine suddenly stops beating? The timeline is incredibly urgent. Without blood flow, the brain is deprived of oxygen within mere seconds, leading to a rapid loss of consciousness. Within minutes, permanent brain damage can begin. This is exactly why immediate action is everything. CPR, or cardiopulmonary resuscitation, is a way to manually pump the engine from the outside, keeping blood circulating. Meanwhile, modern medical devices called defibrillators can be brought in to deliver a carefully controlled electrical shock, effectively trying to reset the SA node and restore that vital, natural rhythm.
Which brings us to our final thought. The heart is absolutely one of the hardest working, most efficiently designed structures in the known universe. Because of a tiny natural pacemaker, it pumps oxygen to every cell in your body. It happens while you're awake, while you're asleep, and even while you dream. Every beat is, quite literally, a miracle of biology keeping you alive. So I'll leave you with this. If you are gifted roughly 3 billion beats in your lifetime, what will you do with yours? Keep learning, keep asking questions, and we'll see you on the next explainer.